In this movie, I want to explain what distributed version control means so we can understand why this is such an important feature of Git. In the previous movie, where we looked at the history of version control systems, we talked about SCSS, RCS, CVS, and SVN, four of the most popular version control systems of the past. And all four of these use a central code repository model. That is, that there's one central place where you store the master copy of your code. And when you're working with the code, you check out a copy from the master repository, you work with it, make your changes, and then you submit those changes back to the central repository. Other users can also work from that repository, submitting their changes. And it's up to us as users to keep up to date with whatever's happening in that central code repository, to make sure that we pull down and update any changes that other people have made. Git doesn't work that way. Git is distributed version control. Different users, or teams of users, each maintain their own repositories instead of working from a central repository. And the changes are stored as change sets or patches. And we're focused on tracking changes, not versions of the document. Now, that's a subtle difference. You may think, well, CVS and SVN, those track changes too. They don't. They track the changes that it takes to get from version to version of each of the different files or the different states of a directory. Git doesn't work that way. Git really focuses on these change sets and encapsulating a change set as a discrete unit. And then those change sets can be exchanged between repositories. We're not trying to keep up to date with the latest version of something. Instead, the question is, do we have a change set applied or not? So there's no single master repository. There's just many working copies, each with their own combination of change sets. Let me give you an illustration to make this clearer. Imagine that we have changes to a single document as sets A, B, C, D, E, and F. We're just going to give them arbitrary letter names so that we can help see it. We could have a first repository that has all 6 of those change sets in it. We can have repository 2 that only has 4 of those changes in it. It's not that it's behind repository 1 or that it needs to be brought up to date. It's just simply that it doesn't have the same change sets. We could have repository 3 that has A, B, C, and E, and repository 4 that has A, B, E, and F. No one of these is right, and no one of these is wrong. None of them is the master repository, and the others are somehow out of date or out of sync with it. They all are just different repositories that happen to have different change sets in them. We could just as easily add change set G to repository 3, and then we could share it with repository 4 without ever having to go to any kind of central server at all. Whereas with CVS and SVN, for example, you would need to submit those changes to the central server, and then people would need to pull down those changes to update their versions of the file. Now, by convention, we often do designate a repository as being a master repository. But that's not built into Git. It's not part of the Git architecture. That's just convention that we say, okay, this is the master one, and everyone is going to submit their changes to the master one, and we're going to try and all stay in sync from that one. But we don't have to. We could actually have 3 or 4 different master ones that have different versions, different features in them, and we could all be contributing to those equally and just swapping changes between them. Now, because it's distributed, that has a couple of advantages. It means that there's no need to communicate with the central server, which makes things faster, and it means that no network access is required to submit our changes. We can work on an airplane, for example. And there's no single failure point. With CVS and SVN, if something goes wrong with that central repository, that can be a real showstopper for everyone else who's working off of that central repository. With Git, we don't have that problem. Everyone can keep working. They've each got their own repository that they're working from, not just a copy that they're trying to keep in sync with a central repository. It also encourages participation and forking of projects. And this is really important in the open source community because developers can work independently. They can then make changes, bug fixes, feature improvements, and then submit those back to the project for either inclusion or rejection. And if you decide you don't like the way that an open source project is going, you can fork it, take it a completely different direction and say, you know what, I'm going to just make a clean break and make my repository now the one that I'm going to work from. All of my changes will be submitted to there, and I can still pull change sets from the master one into my project whenever I want, but I don't have to. I can go my own way. That becomes a really powerful and flexible feature that's well suited to collaboration between teams, especially loose groups of distributed developers like you have in the open source world. Distributed version control is an important part of the Git architecture that you need to keep in mind, especially if you have previous experience with another version control system like CVS or SVN. We'll talk a lot more about how Git tracks and merges these change sets as we go forward. For now, just make sure that you understand that there is no central repository that we work from. all repositories are considered equal by Git. It's just a matter of whether a repository has change sets in it or doesn't.